Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 15, 2026, just 2 days ago. It introduces a new framework for training deep search agents that hits a score of 80.1 on the GIA benchmark, significantly outperforming proprietary models like GPT-5 Thinking High. The paper is titled REDSearcher, a scalable and cost-efficient framework for long-horizon search agents. And as we'll see later, the implications for creating high-quality training data at scale are really significant. Figure 1 displays the model's performance across 6 key benchmarks. On the text-only side, specifically the GAIA chart in the bottom middle, REDSearcher hits that 80.1 score, outperforming strong proprietary models like GPT-5 Thinking High. The rightmost column covers multimodal results, where the model remains highly competitive. On BrowseCompVL, for instance, it scores 57.2, edging out Gemini 3 Pro. Alright, Figure 2 illustrates how the authors define task difficulty using a metric called tree width, which measures how entangled the reasoning steps are. On the left, tree width 1 represents a simple linear chain, where a model can solve the problem one step at a time, like tracing a family tree. However, the center panel shows tree width 2, which introduces cycles. Here, answering the question about The Godfather Part 3 requires satisfying multiple constraints simultaneously, checking the director, actress, and characters all at once, which prevents the model from using simple shortcuts. Now, Figure 3 details the pipeline used to manufacture these complex tasks. The top green panel shows the QA generation phase, which starts with seed entities and builds a massive topology-enriched graph from Wikipedia and the web. It then samples specific substructures that meet those high-difficulty criteria, converting them into queries that explicitly require tools to solve. The bottom blue panel outlines the verifier pipeline, which rigorously filters these questions. It ensures answers aren't trivially available in search snippets, and uses an agent solver to confirm the tasks are valid. So, with the data pipeline established, Figure 4 maps out the actual training recipe. The authors introduce a distinct mid-training phase to bridge the gap between a raw open-source model and a specialized agent. This mid-training splits into 2 parts. Stage 1 focuses on atomic capabilities like specific tool use within a 32K context, while Stage 2 expands to composite capabilities with a 128K context for long-horizon planning. After that foundation is laid, the model moves to the post-training phase, which refines behavior through Agentic SFT and reinforcement learning. Well, having seen the training recipe, Table 1 now presents the head-to-head performance comparison across 4 major benchmarks. The rows are grouped by model type, with proprietary giants at the top and the 30 billion parameter class near the bottom. In that final section, REDSearcher achieves a state-of-the-art overall score of 51.6. The standout result appears in the GAIA column, where it hits 80.1. This score not only beats its direct open-source competitor, Tongyi Deep Research, by nearly 10 points, but also surpasses proprietary heavyweights like GPT-5 Thinking High on that specific complex reasoning task. While the previous table focused on text, Table 3 shifts to multimodal search benchmarks, where agents must process visual evidence. The table groups models by type, with proprietary giants like Gemini and GPT-5 at the top and open-source baselines in the middle. At the bottom, REDSearcher's 30 billion parameter model shows strong performance. On the BrowseComp versus L column, the reinforcement learning version scores 57.2. This result edges out Gemini 3 Pro and substantially outperforms the massive QN3VL, which has nearly 8 times the parameters. Wrapping up, REDSearcher demonstrates that intelligent synthetic data generation can bridge the gap between open-source models and proprietary giants. By carefully engineering task difficulty, the authors created a 30 billion parameter agent that outperforms massive systems on complex reasoning benchmarks. This points toward a future where data quality drives progress as much as model scale. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.